Hello, my name is Avery Hutto, and today we're looking at what makes a state livable, a data-driven look at life across the US. The point of interest slash purpose, so I wanted to explore what makes a state a great place to live. After college, we're going to be looking where we want to settle down, looking at these types of factors, and so it's relevant to us in the near future. I wanted these data sets because I wanted to look at different factors on choosing where to live. I want to look at storms, schools, and happiness. And I also wanted to see if choosing Georgia was a well-informed decision that my family made and how good of a state it is. Um, what am I expecting to find? I'm expecting to find some sort of correlation and causation between states with more damage having a lower quality of life and states with more schools might having a higher quality of life or increased happiness. And I also would hope to see that Georgia would rank well overall. So I collected four data sets. So I have a CSV file, which is from the National Center for Environmental Information. They publish historical storm content, basically reports. I web scraped in HTML on life quality and happiness from the Population Review. They just rank the states and compile happiness and well-being scores. I then have an API from the National Center for Education Statistics. This API just provides school locations so I can see how many schools are kind of in each area. And then my last data set is a CSV, which came from the same website as my other CSV file, just providing a little bit of different data. Okay, data cleaning. I first cleaned my CSV file. I converted um, some dates into a more strict format with month, day, year, so I can compare this to other data sets. I standardized state names using the US module. I removed some letter values from numbers just to clean it up a little bit. And I calculate the average damage event type and filled in missing damage values in this data set. And then I just built a clean data frame. Then for my web data set, I use Selenium to open the web page, which is a new module for me. I parsed the web page with Beautiful Soup, read the table using pd.read.html. I standardized state names, and I cleaned up some of the numbers in that as well. And I calculated a quality of life score using a weighted formula combining happiness and well-being rank. For my third data set, I have an API. I used the GET request to grab the API and I extracted the features and attributes from that API. I converted the extracted attributes to a Panda data frame to make it easier to work with, keeping only the relevant columns that I needed. Using the US module, I also standardized those state names and I filtered the dataset to include only schools located in major US cities just for cleaning purposes. My last data set, I opened that CSV file, extract the year, the month, the day, standardize the date, and I got the values that I needed and converted the collected list into a pandas data frame. Okay, data analysis slash insights. Okay, what was my objective with this analysis? I want to identify which factors influence state livability the most, measure how damage and frequency vary across states. I want to use machine learning to predict high versus low quality of life states, just sort of determining what states are good, what states are bad, and in particular, determining whether Georgia ranks as a strong livability choice overall. Okay, insight one. I did two things with this insight, but they're pretty much the same. So I removed any leftover index columns, I aggregated storm data, I merged the storm totals with life quality scores using state abbreviations, and I filled missing data values and applied a log transform that I learned from website in my code. That's linked in my code. And then calculated the correlation between storm damage and quality of life and displayed the top 10, which you can see up here. I also did this with the school data set that I have, and I compared it also to the quality of life to see that correlation, which you can see over here. And both kind of showed a very low correlation, which I was kind of shocked to see. But you can look at states with more of a high correlation up here. For Insight 2, I loaded the clean storm data set. I extract the year from when the storm began. I grouped the data by state and the number of storms by each state experienced annually. I grouped again by state to calculate the average number of storms per year per state, sort the results, and return. So this was just kind of looking at the frequency of storms per year. So you could look at these results and be like, oh, Georgia has pretty frequent storms per year. Maybe I should think about, is that the best choice for me? Okay, Insight 3. This is where I use my linear regression model to compare all three of my data sets together to see if the quality of life score works as the target. So I got all my data, I select the key features, log damage, storm count, number of schools, number of cities. I set the quality of life score as the target. I split the data into training and testing using training test split, train a linear regression model, and then predict the quality of life on the test set. And I evaluated using R squared and RMSE, and you can see these evaluations here. In Site 4, I used the random forest classifier machine learning module. So I created a binary label that classifies states as high quality of life. I selected my features. I trained a random forest classifier, I generated a classification report and display. And you can see this report here, but you will also be able to see it better in one of my visualizations. Okay, for Insight 5, I um, got the range severity for my extra data set, and I'm comparing that to the storm damage from my first data set. So I grouped the extra data set by location. I display the top locations with the highest range severity, um, grouped the storm events and displayed that. And I also averaged the range severity and number of events recorded at each location. And I averaged the damage too. Table of visualizations. Okay, so my first visualization is derived from my first insight, storm damage versus quality of life. So you can kind of see here, which there's not a lot of correlation, but I think there's something really helpful about this graph. Let's say you have a few states you're considering. Let's say storm damage matters a lot to you. You can go lower on the storm damage graph and maybe not as high on the quality of life. Let's say quality of life matters more to you. Higher on quality of life, maybe storm damage doesn't matter as much, in my opinion. That's where you can get that information. Visualization 2, this is from my Insight 4 from that random forest model. Here you can see a choropleth that shows kind of what it identifies as high quality of life versus low quality of life, and Georgia isn't that high quality of life. Okay, visualization 3 is where we have um, I had to add the states here because these events were not easily able to code into like identifying them as states, but you can see here how we compare storm damage to range severity. And there are some states like Arkansas that are on both, and those states might be ones you want to avoid. They have high range of storms, so a lot of the state is covered by storms, and they have a lot of storm damage, so a lot of money is given up to kind of help that storm damage. Okay, what did I learn? I learned how to deal with large, messy data sets, how to use Selenium and Beautiful Soup. I learned how to clean a data set using handling missing values or inconsistencies. I learned how to use machine learning and um, scikit-learn and to transform bias or skewed data using log transformations. And how to create visualization using Plotly. I sort of knew this, but I got to refresh those skills. And last, what states appeared the most optimal overall results and conclusions? We saw that Utah, Minnesota, Colorado, Washington, and Massachusetts were the highest. They had the um, low environmental disruption, strong educational infrastructure, and high resident well-being. They avoid extremes elsewhere, not too many storms, and they are clustered together in the high quality of life. And is Georgia a good choice? Yes, Georgia falls in competitive middle to upper range across happiness, quality of life, and school access. Georgia has a higher storm frequency than many states, but it has good happiness score and education presence, so it is high quality of life. So, yeah, that's all I gained from this, and thank you for listening.